Okay, we will continue our discussion about the fuzzy linear programming. In the previous sessions, we discussed about the structure of fuzzy linear programming in many states. In the first state, we explained about the fuzzy maximum or constraint, less than or more than, or greater than. And the second state was about the coefficients of fuzzy objective function. And in this state, we are going to discuss about the technological coefficients and the right hand side in the constraints. For example, sometimes the technological coefficients of this constraint can be considered fuzzy numbers, and sometimes the right hand side numbers can be considered fuzzy. And in this structure, we assume that both coefficients, technological coefficients, and right hand side numbers are in the state of fuzzy and triangular fuzzy number, especially simultaneously. And what should we do? There is a simple way to consider the average of fuzzy numbers and converting these triangular fuzzy numbers to the crisp number, as you see previously. Another way is to consider the triangular fuzzy number and uh, to differentiate the structure of uh, fuzzy numbers uh, to make several constraints. How uh, can we do this uh, separation? Okay, for example, uh, you must envisage to this model maximum z equals cx subjected to sigma aij xi e pi in the crisp condition. Excuse me, xj are greater than 0. J from 1 to n are added. Okay. For each constraint, you have this inequality. And in this situation, we are going to assume that there are fuzzy numbers for coefficients and right hand side numbers. A fuzzy equals A pessimist, A moderate, and A optimist. And for B, you consider B pessimist, B moderate, and B optimist. Okay. In this state also there are triangular fuzzy numbers for A, for example, and for B. BP, BM, BO. Then we consider three parts for the constraint. For example, if you have one constraint with fuzzy numbers, you can differentiate one constraint to the three constraints. How? With these parts. The first, difference between AM and AP. Other, AM. And other is the difference between AO and AM. Then, for the right hand side number, you can also consider this situation. For example, for this part, the left part of triangular fuzzy number is written like this: BM minus BP and BM, and other part, the right of triangular fuzzy number equals to BO minus BM. So you can separate the one constraint to the three constraints. Then we can rewrite the model as you see. I must say that in this model, the researchers didn't consider the membership degree or membership function structure, and they didn't pay attention to this structure, and just they take into account the numbers without considering the lambda or mu with a structure of membership function. So, in the first place, we write AO, AM minus AP x less than BM minus BP and AMX is less than BM, and in the third constraint we assume that AO minus AM multiply x is less than B O minus B motor. And it is possible these, for example, this constraint related to many general constraints in this structure. And x is more than 0. This is the structure of crisp linear programming instead of structure of fuzzy linear programming. You could convert the fuzzy linear programming using triangular fuzzy number for A and triangular fuzzy number for B. And in the other state or last state, we assume that the model like this: maximum z equals cx and subjected to the constraint ax is less than b, fuzzy b. Only in this structure the right hand side numbers are fuzzy. Fuzzy like this plot. From this point, B decrease number and B plus P for each constraint, Bi plus Pi, and mu y, the variable instead of B, for fuzzy B. As you know, this structure is related to the minimum objective function, or minimum objective function is equivalent to this constraint that you see. In this constraint, we have almost fuzzy B, and we can accept the value for B with lambda as membership degree. If we can maximize lambda, we are going to dwindle the distance between y and bi. We are decreasing the interval between y and bi, and we are approaching to the crisp b or crisp bi. This structure is similar to the structure of fuzzy membership function, fuzzy objective function, and fuzzy coefficient of objective function, as you remember this structure. Okay, in this state we can determine the objective function for right hand side numbers. For example, this equals 1 before bi is less than b or bi. We consider b in structure, general structure, and y minus b divided by p. What is the p? P is exactly the allowable deviation, as you saw before in the structure of maximum fuzzy or minimum fuzzy for obtaining the membership function. And this is tolerance. Y minus b excuse me, in this structure we must obtain this part, b plus p minus y divided by b plus p minus b, and the conclusion of this calculation equals to the p in this part. Okay, and y between b and b plus p, and 0, the membership degree equals 0 for y greater than b plus p, as you see in this part, and 1 as you see in this part. Okay, and for a constraint that are greater than the right hand side, you must change this equation fraction. For example, in this structure, max z equals cx with subjected to ax are greater than b you assume that this plot for the structure of a membership function, as you see, this is b, the membership degree for the value greater than b equals 1, y variable instead of b for fuzzy b. Y greater than b, and for y is less than b minus p, and this distance equals p. And the fraction is obtained by divided. For example, y minus b minus p divided by p, y between b minus p and b. And this is another formulation for membership function in this state. So, because of fuzzy feasible region in this structure, we should consider the structure of objective function as fuzzy, because the feasible region is fuzzy, and we are going to consider the structure of objective function as fuzzy. And for this purpose, we can rewrite the standard fuzzy linear programming For example, ax less than b to this structure. ZL can be calculated by solving the maximum Z subjected to ax is less than b, and Z upper is obtained by solving the maximum Z subjected to ax less than b plus p, the tolerance. The value that we considered for violation of the right hand side. Okay. Then we can rewrite the membership function for objective function also. According to the maximum objective function, we are using this structure. Z upper, Z lower, and the distance between Z upper and Z lower. This is 1 if Z or Cx. It's better we use the Cx is greater than Z upper, and this is 0 for Cx is less than Z lower, and this fraction Cx minus Z lower divided by Z upper minus Z lower, and the Z is between Z lower and Z upper, and this is at least lambda, as you know, according to the previous descriptions about this structure. So lambda ZU minus ZL minus Cx is less than negative ZL. This is formulation for objective function, fuzzy objective function. Then you are going to maximizing the lambda. So this model with fuzzy right hand side can be rewritten like this. Maximum lambda subjected to lambda multiplied Z upper minus Z lower minus Cx is less than negative ZL, and Ax plus lambda p or p lambda is less than p plus p, and x and lambda are greater than zero, or now negative numbers. Okay, and now we explain 4 states for fuzzy linear programming. The first state is related to the maximum or minimum fuzzy or constraint fuzzy. Constraint are considered fuzzy. Second state, in the second state, we assume that just the coefficients of the objective function are assumed to be fuzzy. And in third state, we have assumed that A and B respectively as technological coefficients of constraint, and the right hand side numbers are assumed to be fuzzy. And in the fourth state, we have assumed that just B is fuzzy. So in this structure, the researcher considers C pessimist, C moderate, and C optimist instead of fuzzy C. And in this structure, they also consider the triangular fuzzy numbers instead of A and B. But in this state, they assume that the B is violated with the allowable deviation, and this structure also the researcher assumed that the objective function, the value, the best value or optimum value for objective function is violated according to the maximum and minimum so that we can consider the lambda. And in the structure, third state, the lambda is not considered. Okay. In the next session, I will give suitable examples for each state, the first to the fourth, and I will try to solve the model by using the GANs as commercial software.